So here comes some solutions to the AB Chapter 3 practice set. So first up, number 1, we've got y squared equals 8x, and we're just being asked to go find dy dx. So we jump right in with some implicit differentiation. Y squared turns into 2y dy dx, and of course the right side will just become an 8. And we'll divide both sides by the 2y and simplify, and we'll get dy dx equals 4 over y. And that would be it. Next up, number 2. Let's see, this time they give us f of x equals, what was it, 5 to the x. So this is just a derivative rule you're supposed to know. I call it a repeater, 5 to the x, and then ln of the base, 5 to the x ln 5, and that's it. That's number 2. Next up, number 3. Number 3, they gave us some inverse tangent. So sorry, y equals inverse tangent of, and let's see, it had a square root of 3x. Probably going to rewrite that first, yeah. So let's go inverse tangent of 3x to the 1/2. Something like that would be good. So our derivative, we'll start with the outside function, that would be inverse tangent, is 1 over 1 plus stuff squared. And the stuff is what's sitting right here, or you could say right here. I'm going to take that whole thing, and I'm going to take square root of 3x, and I'm going to square it. But then I still have to multiply by the derivative of the stuff, so that would be times the derivative of the 3x to the 1/2. So that would be 1/2 times 3x to the negative 1/2 times the derivative of its stuff, which is a 3 out there. And then it's just a matter of cleaning it all up. So on the bottom, we'll just have 1 plus the rad 3x quantity squared just becomes a 3x. And then we've got the 3 on top. This 2 can go down to the bottom, right, because it's a 1/2, so it's 1 over 2. And then the 3x, because of this negative power, we can move it to the bottom, so it's 3x to the positive 1/2. And that turns into simply 3 over 2 times the quantity 1 plus 3x times the square root of 3x. And you can reorder this in lots of different ways, but that would be a great final answer right there. All right, next up, I'm going to skip around a little bit. Number 5 is a small enough one we can fit it right in here. We have y equals log base 4 of 7x. You could do a rewrite if you wanted to, but I'm just going to jump right in and take the derivative. So anytime you have a log, it's 1 over the stuff times the derivative of the stuff. But this time there's a base of 4, so we have to put an ln 4 on the bottom. And we're almost done. Of course, you can get rid of the 7s here and rewrite your final answer as 1 over x ln 4. Now, had you done the rewrite, we could have first just called this y, that's an arrow, y equals log base 4 of 7 plus log base 4 of x. So then when you take the derivative, this is a constant, it goes away right away. And then you're really just taking the derivative of log base 4 of x, which makes sense when you think about how the 7s disappeared. Well, the 7s disappeared, right? All right, next up, number 4. Number 4, we are given tangent of xy equals 6x. So we'll take the derivative of the left side and get a secant squared of the stuff, don't change the stuff, times the derivative of the stuff. So that'll be a little f and a little g. We got a little product rule there. So we'll go g times derivative of f plus f times the derivative of g. And then we'll go take the derivative of the right side. Now keep in mind, our goal is to get dy dx by itself. So what we'll have to do is distribute the secant squared to break down the barriers. And then from there we should be able to simplify things. Oh, I just realized something. I put a g. When I said g, I should have said g but written y. So y is my g, times the derivative of x. Okay, there we go. All right, so we're going to have a y times secant squared of xy. And you do not get to multiply the y in there to the xy. Next, we've got an x dy dx with a secant squared xy on it. And that's equal to 6. Next up, we'll subtract this over to the other side. Easy enough. You know, it's a big messy term, but we can subtract it just like any other term. And then we'll be left with, I'm going to rewrite this. I didn't like the order I put there last time. So x secant squared xy times the dy dx. There's our prize, right? Keep your eye on the prize. Oops, we got a 6 minus y secant squared of xy. All right, so next step would be to just divide by this guy, and it'll pop up on the other side. So we'll get dy dx equals 6 minus y secant squared of xy. And then just divided by x secant squared xy. And that's a great final answer right there. You could, if you wanted to, you could rewrite this. And it's not too crazy to think that maybe split it into two fractions. So we'll have 6 over the x secant squared xy minus y over x. If you didn't see it, they both have the exact same secant squared mess. So this right here, that's a pretty decent answer as well. I don't think I wrote that up on the PDF version, but if you get to here, that's fine too. All right, so that's number 4 and number 5. Number 6 is actually the same. No, it's not the same. So number 6 will sneak in up here. About, let's see, y equals tangent cubed of negative 2x. So dy dx, we'll start with the outside function, which I probably should rewrite this with a cubed outside. And then we get tangent of negative 2x on the inside. So the outside is the cube, and then inside that would be the tangent, and inside that would be the negative 2x. So following our rules of outside on our way in, the derivative of stuff to the third is 3 stuff to the second. Oops. Sorry about that. It's not an inverse tangent. So 3 stuff to the second times the derivative of the stuff, which is secant squared of the stuff, times the derivative of its stuff. Okay, so we got function inside a function inside a function. And now we'll just go take coefficients and put them together. That 3 times that negative 2 can go out front. So we'll go negative 6. And then this squared can go back on the tangent, so we can get rid of some of the brackets. It just gets a little messy when you got too many parentheses, too many brackets. And then we can follow it up with a secant squared of negative 2x. And I believe that is how I'd leave that one. That's a great final answer. All right, that's number 6. Moving on. Let's go to 7. So number 7, they've given us x to the 10th plus 5xy. I'm seeing a product plus a 20x equals a 4. So we'll start with the simple. We got this 10x to the 9th plus, I'm going to deal with the 5x times the y as an f and a g. So we'll have a g times f prime plus f times g prime. And of course, derivative of 20x is just 20. Derivative of 4 is just 0. We're going to move some stuff over. Leave this guy here. Everything else moves over to the other side. So 5x dy dx. And you're moving these things with subtraction, right? Subtract that over, subtract it over, subtract it over. So we'll have maybe a negative 20 minus 5y minus 10x to the 9th in whatever order you choose. And then we're going to divide everything by 5x. And that should get us our final answer. We may need to be reducing it at the very end. I'm not sure. Let's see what happens. Oh yeah, we should get rid of the 5 there. So 5 goes into all of these guys on the top. Maybe we'll show that step. So divide out a 5, and that leaves a negative 4 minus y minus 2x to the ninth. And then, of course, there's a 5 times x down here. We'll cross off those 5's, and we'll leave a final answer of negative 4 minus y minus 2x to the ninth all over x. And that would be a good final answer right there. Of course, there are different forms. I think on the PDF I left the negative out in front, which is not my favorite thing to do, but then you could leave these as all positive and maybe reorder it. Let's just be careful here. That negative is out front. It's not here. Okay, that's dangerous. So let me get rid of that guy. And let me clean that one up a little bit. So just make sure that negative is right out in front of the whole thing. Okay, so great final answer as well, but I prefer this guy. All right, moving on. Let's see here. Number 8 was actually a repeat, so we're going to skip that one. Sorry about that. And then we got a true or false. Number 9 coming up. They said y equals ln of x to the ninth. And they want us to find out if dy dx really is just 9 over x. And well, we could do just straight up derivative right now without a rewrite. 1 over the stuff times the derivative of the stuff. And then we can reduce a little bit. That turns into 9 over x because 8 of these cancel 8 of those. So that would be a true. Okay, so that's that. Next up, number 10. Switch some color here. Got some blue. So what is number 10 asking for? We've got find f prime of x, given f of x equals ln of 4x times the root 2 minus x squared. Now you probably don't want to go at this head on, just usual, take a derivative right away. You probably want to rewrite this. So I'm going to do that first. I'm going to write it as ln of 4x plus 1/2 ln of 2 minus x squared. And I'm capitalizing on the fact that 2 minus x squared is a 2 minus x squared to the 1/2. And then the whole bring the power down when you can because you have a log out in front. I could have also pulled this ln4 off and called it ln4 plus ln x, but it's easy enough to take a derivative of ln of 4x. So here goes, 1 over 4x times the derivative of the 4x, which is 4, plus 1/2 times the derivative of ln of the stuff is 1 over the stuff, times the derivative of its stuff. Make sure you get a times symbol there. Clean it up a little bit. You'll get a 1 over x plus, or should I say minus, let's go minus because of this guy right here. We'll take that negative 2 and bring it out front. In fact, the 2's will cancel, so that's kind of nice. But I'm going to take that, that's a really big negative sign. I'm going to put a negative sign right here because of that negative sign right there. And then we'll go ahead and finish up the rest. It'll be x over 2 minus x squared. That's a great final answer. If you want to try to get common denominator, have at it. I don't need you to do that for me. All right, next up, number 11. We've got x to the 5th minus inverse cosine of y equals ln x. Now we're taking the derivative of inverse trig. You got to just know those derivative rules. If you don't, study them. You need to just know them. So we get 5x to the 4th minus, it'll be negative 1 over the square root of 1 minus the stuff squared, and the stuff is just the y, and there's a negative because it's inverse cosine, and then we have to multiply by the derivative of the stuff, which is dy dx. And of course, derivative of little ln x is just 1 over x. At this point, we'll move the 5x to the 4th over. These negatives will cancel. So we'll have a 1 over root 1 minus y squared dy dx equals 1 over x minus 5x to the 4th. And let's see. Got a little bit more to do here. We just want to get rid of that root 1 minus y squared there. So we'll go multiply both sides by root 1 minus y squared. Do the same thing over here, root 1 minus y squared. All right, so that means these are gone. I get a nice dy dx on the left. And you can just copy this down as is. If you want, you can put the root in front.